Okay, good morning. Let's revise now the chapter 10. Let's start with this question here. Use the triangle below, find the missing side length, if necessary, round to the nearest tenth. Now, as you see here, we have a right triangle. We said that for the right triangle, to find the length of the sides, we have to use the Pythagorean theorem to find the missing angles or with the missing sides. If the angle is given, I have to use the trigonometric ratios. Here now, as you see, we have the length of the sides. They asked me to find the length of the missing one. For the triangle ABC, let's solve number 1. If A is 28, if B is 35, find C. This is number 1 here. Now, the Pythagorean says that the Pythagorean theorem that the hypotenuse squared equal the first leg squared plus the second leg squared. Then after that, 28 squared is 784 and 35 squared is 1225. They are equal C squared. Then I will add them. Equals C squared. Now how we find C? By putting this number under the square root. So the square root now of it is, we can say 7 square root of 41 or 44.8. This will be now the answer. So the hypotenuse of this triangle is 44.8. Now, here, as you see, the first side here is 28 and the second side is 35. The hypotenuse, it must be greater than them. And as you see here, 44 is greater than 35 and greater than 28. So my solving here, oh, this is correct. But if they are less than them, there's something wrong. Now let's solve number 3. In number 3 here, also we have this triangle A, B, and C. And if B is 4, C is 4.1, you have to find A by Pythagorean theorem. But here C is none. So for C squared, which is A squared plus B squared, 4.1 squared equals A squared plus 4 squared. 16 plus A squared equals 4.1 squared, which is 16.81. Then A squared is added to 16. The opposite of adding is subtracting. So A squared here is 0.81. So A will be the square root of 0.81 or 0.9. Now, is it clear?
Yes, teacher.
Okay.
Yes.
Now let's go to this question here. State whether statements of the given length can be the side of right triangle. For this one here, they give me the length of the triangle. I want to check if they are a right triangle or no. How? Now, here we have now 7, 24, and 25. Which is the greatest one? It's a 25. So the greatest one, which is will be the hypotenuse. Then the other will be therefore the sides. Now, let's see if this is a right triangle or no. What we have to do? We have to say, let's check if c squared, is it equal to a squared plus b squared? I mean, is it 25 squared is equal to 24 squared plus 7 squared? Now let's see. 24 squared is 576 plus 49. When you added them, they are 625. And 25 squared is 625. So as you see here, is 625, which is 25 squared, equal 576 plus 49?
Yes.
Yes, since they are equal, since c squared equal a squared plus b squared, so I will say that means the triangle here is right. Now, let's go now to lesson 2 to see how can we simplify the radical expression. Let's do now number 8 here. Number 8, we have square root of 3 plus square root of 12. They are different, 3 and 12. I cannot add them. If they are under the radical are different, I cannot add them. I try now to make 3 to be as 12 or 12 to be as a 3. It's easier for me to make 12 as a 3. Now, how? Keep the square root of 3 because it's already the simplest one, and try to simplify 12. Now, how you simplify 12? Come here, ask yourself two numbers that if I multiply them, I get a 12, and one of them is a perfect square. What are these two numbers?
4 and 3.
3 times
4
4.
and 4. Bravo.
4 and 3.
So I have 4 and 3. So I will say now, square root of 12, it will be written as square root of 4 times 3. Then I can distribute the square root since they are multiplied. And as I told you, remember, if they are multiplied only, you can distribute the square root. If they are added, you cannot, or subtracted. If they are multiplied or divided. So here, since the two numbers are multiplied, I can distribute the square root on them. So we have square root of 4 times square root of 3. Then now, square root of 4 is 2, square root of 3. So square root of 12, I can write it as 2 square root of 3. So let's write it here now as 2 square root of 3. Then if you have x plus 2x, what's the answer?
3x.
3x. Bravo.
3x.
And here, if you have 1 square root of 3 plus 2 square root of 3, when you added them, what did you get? 1 plus 2 is a 3 square root 3 square root of 3.
Okay, teacher.
Okay. Now,
Okay, miss.
let's solve number 9. Square root of 300. Here, 300. Let's ask myself now about two numbers. If I add, multiply them, I get 300. And one of them is a perfect square number.
100.
أيوة.
No. Yes, 100.
103. Bravo. So 300 can be written as square root of 100 times 3. Then after that, let's distribute the square root onto 103. So I get it as square root of 100 times square root of 3. Then what is the square root of 100?
10.
It is 10.
10.
Square root of 3.
10.
So square root of 300 is 10 square root of 3. Is it clear?
Yes, teacher.
Yes, teacher.
Yes, miss.
Okay.
Yes.
Now, as I told you, remember, if the number under the square root is a prime number, or if it is a compound number, but these two factors are prime, you will not simplify it. Like number 10 as an example. As we said before, number 10 is 5 and 2. So when you factorize them, you find that the two numbers are prime. So you have to stop. You can keep it as square root of 10. But like 300, one of these two numbers are perfect square or are a compound and not prime number. So we have to continue. So if it's prime or product of two prime numbers, you can stop. This is when you have to stop. Now let's do number 11. In number 11 here, we have negative square root of 18 over square root of 12. Now here, I want now to divide them. As you see, divide, it's mean I have to simplify to cancel the common product or the common factors. Now 18. Give me two numbers that if you multiply them, you get 18.
9.
9 and 2. Okay. 12.
4
3
and
and
3.
4.
4 and 3.
And 3. Bravo.
4 and 3.
Now let's come now to the numerator here. We have to say it is negative square root of 9 times square root of 2. I have to distribute the square root over square root of 4 times square root of 3. Then, what is the square root of 9?
3.
3.
3.
Don't forget the negative sign here. So negative 3 square root of 2 over, what is the square root of 4?
2.
2 square root of 3. So the final answer here is negative 3 square root of 2 over 2 square root of 3. Is it clear?
Yes, teacher. Say.
Yes, my sister, are you hearing me?
Sorry?
Yes, teacher, it's clear.
Okay. Now, let's go here to the radical equations. How can we solve them? In the radical equations here, as you see, now we say that this one is a radical expression. But if you have it like this, we call it radical equation. And since it is equation, we need to solve them. So number 16 now. Square root of 27 plus 4 equals 7. What is the first step here?
Um,
Teacher, we will
will
subtract 4.
minus 4.
Yeah, you have to subtract 4 from both sides. Because I want now to put a radical number or radical expression on a side and a number on the other side. Like you mean you have to isolate the radicals. So square root of 2x is 3. Then how can I cancel the square root?
Square.
By
squaring.
Bravo, you have to square both sides. So like it will be distributed like this if you square it. So the square cancel the square root. So I have 2x equal 3 squared, which is 9. Then 2 times x. I don't want 2x, I want x only.
We will divide
by 2
the both sides by 2.
2 from
Bravo.
both sides.
So divide by the both sides, so you get it as 9 over 2.
4.5. Oh,
Now, let's solve number 17. Square root of k minus 8 equals 28. What do you have to do here?
plus 8 plus 8.
Plus 8 from both sides.
Bravo. Plus 8 from the little. So square root of k is 28 plus 8, which is 36.
36.
Now, square root of k is 36. I want k only. What I have to do?
We will
Square
square
the
the
both
both
sides.
sides.
Yes, square the both sides. So k will be 36 squared, which is 1,296. This will be now the value of k. Now, when you want to check your solution, what do you have to do? Put this number under the square root, like 1,000 or square root of 1,296, which is 36. 36 minus 8. Is it 28? Yes. So that means my solution or my solving here is correct. So in number 18 here, the first step, you have to multiply by 3. So because I want to isolate the radical. So square root of 3m plus 2 equals 3. Then I want to cancel. So look here. Here there's nothing beside the radical. So I didn't do anything. Just square the two terms. Square root cancel the square. This one. It will be have 3m plus 2 equals 9. Then minus 2. Minus 2. So I have 3m equals 7. So m or 3m is 7. I want to solve the variable. So I need to find m. Divide by 3.
Divide by 3.
So m, it will be 7 over 3. Is it clear?
Yes,
Yes,
teacher.
ma'am. It's clear.
Okay. Now let's do number 19. In number 19 here, we have square root of 2x plus 4 equals square root of 3x. What you have to do here? Here there's nothing that they are added or divided or multiplied or subtracted by the radical. So you don't do anything, just square the two sides to cancel the square root. Then square cancel the square roots. So I have it as 2x plus 4 equals 3x. Then let's put the x or the variable on a side and the number on the other side. So minus 2x minus 2x. So 4 here is 3 minus 2 is 1x. So the variable now of x here is 4. Now let's check our solution. Let's now substitute. Here we say that 2x minus plus 4 is square root of 3x. So 2 times 4 plus 4. Is it equal square root of 3 times 4? 2 times 4
Yes, miss.
is 8 plus 4,
8.
12. And 3 times 4 is 12. Are they equal?
Yes.
Yes.
So that means
Yes.
this will be, this is a solution. If they are not, I will say now that this is not solution, or we call it an extraneous solution.
Miss,
Yes, Farah.
teacher, but teacher, if the other side was not a square root, it was like 2x plus 4 equals 3x. And we square the side to cross the
You mean
square
like
root
that?
of 2x plus 4.
Or you mean
No,
here?
no, miss, in the equation.
From the beginning? Type, okay, wait a minute.
Yes.
You have it like square root of 2x plus 4 equals 3x.
Equals 3.
Okay.
Yes. So teacher, what we will do? We'll square.
Yes, you have to square the two sides. It will be 2x plus 4 equals. Now here, 3x squared. What does it mean? That means you have to, the power will be distributed on the number and into the variable. So 3, so that means it is 3 squared times x squared, because their power here will be distributed in 3 and x. So I have 9x squared. Then after it comes like this, here, you cannot solve it as a linear. It will be a quadratic equation. The 9x squared minus 2x plus 4. Then you have to open two brackets to solve it.
Yes. Let's define the extraneous solution. One will be extraneous
Yes,
and the
here
other will be
9 times 4 is 36. 9 times 4 is 36. Give me two numbers that if you added them, you get negative, multiplied them, you get 36. And if you added them, you get negative 2. And two negative numbers like this.
If you
36, 40 to 36, we have 3 and 12. We have 6 and 6. We have 4 and 9. So there's no one. If you then here, this. Okay, as you see here now, 36. Even you factorize them, you cannot get as a negative 2. And yeah, I mean when you continue. So here there's no solution for this type of equation. So they will say that it is there's no solution. Because if you try b squared, how I know by that there's no solution? B squared minus 4ac. Let's check. Is it 0 or less than 0 or greater than 0? B squared, it is negative 2 squared minus 4 times 9 times 4. Now from here, 2 squared 4. 4 minus 36 times 4.
Yes, 36. Negative should be negative.
144. So this number 4 minus 144, which is negative 140, it is less than 0. So it means that there's no solution. So you will say that there's no solution here for the radical equation.
Teacher, I have a question.
Yes, Nada.
Teacher, in number 18, I didn't understand the first step we did.
In number 18 here, you have a square root of 3m plus 2 over 3 equals 1. Now I want to solve it. I told you if I want to solve the radical expression, they must be not added or subtracted or divided or multiplied. If they are added to something, move the number to the other side. If they are subtracted, move it to the other side. Here, if they are divided, you want to cancel the number. I want to isolate it. Isolate it, I mean that keep it in a side without adding or multiplying or dividing with any number. So how can I remove this number of this 3? By multiplying by cross product or by multiplying by the reciprocal of 3. When you did this step, you will cancel the 3 because I must cancel it. I must keep the radical sign here or the radical expression isolated.
Oh,
so
okay,
I have it as square root of 3m plus 2 equal 3.
Okay, thank you, teacher.
You're welcome. Now here, we want to graph the function. Now, if in number 22, we have a square root of x plus 2. What does it mean?
The graph will be at the left, 2 points.
Yeah, here we say that it is number 22. We have y as x plus h. So that's mean when I say x plus h, so I have to translate it to the right or to the left with h. So here, since the number is under the square root, so we have a horizontal translation. Since the letter here is h, so h, it's mean horizontal translation. Now then, x plus 2. So what does it mean? That's mean we have to move our parent. This is the parent function. I have to move it 2 steps to the right or 2 steps to the left.
To the left.
The left.
To the left. Bravo.
The left.
So let's repeat it here, or it's clear now. So in number 22 here, we have square root of x plus h. So since the h or the number is under the square root, so I have a horizontal translation. Now then, so since I have x plus 2, so that's mean I have to move or to translate the parent function 2 steps to the left. So this is my parent function here. And I need now to translate it 2 steps to the left. So that's mean that just move this line here 1 and 2. So this will be now x plus 2. This is for number 22. Now, for number 23 now. You have square root of x minus 3. So as you see here, the number is under the square root. So I'm talking about horizontal translation. Now, how did you know? Like, solve it in your mind. X minus 3 equals 0. So x equals 3. So 3 to the right. So here, you have to do the same now. This is the line here. This is the parent function. Now, 3 to the right, as I told you. So here we have 1, 2, and 3. So 3 to the right, like a 1, 2, and 3. So this will be now 3x minus 3. Is it clear?
Yes, miss, it's clear.
Okay. Now, let's solve number 24. In number 24 here, we have y equals square root of x plus 5. Now look at number 5. Where is number 5? Is it inside or outside the square root?
Outside.
Outside. Bravo. So
Outside.
it is like square root of x plus k. So I'm talking about vertical translation. So I have to move the function, the parent function, 5 steps to the up or down.
Up. Up.
Up.
Because
Up. So you have to go 5 up. Then this is the parent function. No, sorry. This is the parent function here. Now I need to move it 5 steps up. So let's say 1, 2, 3, 4, 5. So this will be x plus 5. Is it clear?
yes, miss, it's
Yes,
clear.
teacher.
Okay.
Teacher.
Now
Yes, teacher.
if you have a function like this, such as square root of x minus 3 plus, sorry, I mean like this, plus 4 as an example. In this one here, as we said, what you have to do? We have to put it as, or how to graph it. It is x, first I will draw the parent function. Then x minus 3. So I have to go to the right 3 steps. So 1, 2, 3. Then plus 4. That means I have to go upward 5 steps. Sorry, 4 steps. Then in this side here, at number 3 because I move it to the right first.